A car is moving at a constant speed, say at 25 kilometers per hour. The driver accelerates and speeds up to 50 kilometers per hour in 10 seconds. Now, at what speed is the car moving? What did the driver do, and what is the impact of his action on the velocity of the car? The driver pressed the accelerator to make the car go faster. In other words, he increased the velocity, or you could say the car began to accelerate. Let us learn about acceleration. Zach is going to practice for his bicycle dash to be held in school. He has started moving at a steady speed. Oh, look! He has increased his pedaling. What do you understand by this? Pedaling shows an increase in velocity. Acceleration is the change in velocity of an object per unit of time. Now look at this stationary car. The driver has started the car, and in 10 seconds he increases his velocity from 0 to 40 kilometers per hour. So he was increasing his velocity at the rate of 4 kilometers per hour every second. In other words, the car's acceleration was 4 kilometers per hour squared. Now, let us derive the formula for acceleration by replacing 0 with u as the initial velocity, 40 with v as the final velocity, and 10 with t as the time taken to accelerate. What we get is the formula for acceleration. Acceleration is expressed in units, that is different from the units used for velocity. If velocity is expressed in meters per second, then acceleration would be expressed as meters per second squared. If the moving body increases its velocity by equal amounts in equal intervals of time, then the body is said to have uniform acceleration. Freely falling bodies have uniform acceleration. If the moving body increases its velocity by unequal amounts in equal intervals of time, then the body is said to have non-uniform acceleration. Now observe this car. The driver is driving at the rate of 80 kilometers per hour. As he approaches a speed hump, he slows down his car. In 10 seconds, the speed drops to 30 kilometers per hour. In this instance, final velocity is 30 and initial velocity is 80. The time taken to change velocity from initial to final is 10 seconds. Now, can you calculate the acceleration? The formula for acceleration is this. By substituting the values for v, u, and t, and then calculating, we get the following result. How will you describe this kind of acceleration? Acceleration with a negative value is described as retardation or deceleration. Retardation describes a drop in velocity with time. A car moving at a velocity of 30 km per hour initially increases its velocity up to 50 km per hour in 7 seconds. Later, the car drops its velocity from 50 km per hour to 0 in a matter of 16 seconds. Calculate the acceleration of the car in both cases. Acceleration is the change of velocity per unit time. In the first case, by applying the formula and substituting the values, we get the acceleration as 0.793 meters per second square. In the second instance, the car's velocity dropped and the car came to a halt. By applying the formula and substituting the values, we get acceleration here as negative. This is because its velocity had dropped.